All right, let's do some practice problems. This is from the textbook, 853. Arrange each set in order of increasing atomic size. So the first thing to do would be to locate these three elements on the periodic table. All right, I've got rubidium, I've got potassium, and I've got cesium. All right, well, I know that atomic size tends to increase as we go down a period. So that would mean that cesium would be the largest and potassium would be the smallest. So if I'm arranging them in increasing size, I need to put the smallest first. So it should be potassium, then rubidium, and finally cesium. All right, and then chlorine, potassium, and sulfur. So let's take away these guys really quick. Chlorine, potassium, and sulfur. Well, I can see that I have two elements that are in the same period and one element that is in a higher energy level. The N has increased. So I know that size tends to increase as we go down a period, or pardon me, down a group, and size tends to decrease as we go across a period. So by that token, I'm going to say that chlorine is going to be the smallest and that potassium is going to be the largest because not only is it the furthest to the left, but it's also in a higher energy level. So chlorine, sulfur, and potassium. All right, hopefully that was not too much of a challenge. And like I said, a lot of the stuff today is or should be like relatively familiar. Right. Here is problem 8.82. Write the condensed ground state electron configuration of these transition metal ions and state which are paramagnetic. So first up is vanadium. Let's locate that here. And remember, our condensed ground state electron configuration is going to involve the closest prior noble gas. In this case, we're going to have argon. And I'm going to write down the charge for each of those because that's going to give me a good indication of how many electrons I'm going to be working with. So the charge for vanadium is 23. And then we've got argon. C is equal to 18. All right, so when I'm writing my electron configuration, I'm actually going to start off by writing vanadium as an atom and not as an ion, because for me, that's going to be the most helpful with remembering how to appropriately remove my electrons when we get to that point, because it is a transition metal, so it does not behave in the way that we might typically expect it to. So argon ends with 3p6, so my next orbital is going to be 4s, and then 3d. And that takes us to our 23 electrons of an unionized vanadium. However, as it is a transition metal, when we ionize, we remember that we need to take electrons first from the ns orbital. So in this case, from the 4s orbital, before we take them from the n-1d orbital, or in this case, the 3d orbital. So because we're taking away 3 electrons, we're going to take away 2 from here and 1 from here. So our condensed electron configuration will look like this. Argon 3d2. And then we need to state whether or not this is paramagnetic or dimagnetic. Paramagnetic, remember, means that we have unpaired electrons in our outer electron shells. And since we have 2 in the 3d electron, or in the 3d orbital, we know that we have 5 possible orbitals in the 3d sublevel. That means that those 2 have to be unpaired to maximize our spin, which means it is going to be paramagnetic. All right, hopefully we'll be able to move through silver a little bit more quickly. But let's first locate silver on our periodic table and then go ahead and get started with writing its ionized form. So hopefully things will go a little bit more quickly with silver. I'll let you have a bit more freedom as you work through this. Let's first locate silver. And then, of course, we're also going to have to locate our previous closest noble gas. In this case, it's going to be krypton. So krypton has an electron configuration of 36. Krypton has an atomic number of 36 and silver of 47. So I will let you have a minute to try to work through this on your own. Write out the condensed electron configuration, remove the appropriate electrons, and then state whether or not it's paramagnetic. Right. Hopefully, if you have chosen to write out the if you've chosen to write out the unionized form of silver, you should have krypton, 5s2, 4d, 1, 2, 3, 4, 5, 6. All right, if you have chosen to first write out the unionized form of silver, you should have krypton, 5s2, 4d9. So once again, we are removing our first electron not from the d orbital because we are dealing with a transition metal. We are going to remove that electron from the ns orbital, 5s orbital. So our ionized condensed ground state electron configuration should say krypton 5s1 4d9. And then the question is this paramagnetic or not? Hopefully you're able to say it is paramagnetic because we do have unpaired electrons. So this one is also paramagnetic. Right, and there you have it. You've got some practice problems and you've got some good review of the general trends across the periodic table as pertaining to atomic radius, ionization energy, and electron affinity.